Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about page 6 in the reference table, your water velocity chart. Now this chart got a little bit trickier to read, very simply because of the scales, whether it's the horizontal or the two vertical scales. Let's take a little bit of a closer look and try to explain to you how to read them. The horizontal scale is going to be your stream velocity in centimeters per second, how fast the water is going to be flowing. So we're going to start out with a velocity of 0.01, and you're going to go up to a velocity of 0.1. Each section here, you'll notice, is not an even increase as we go from left to right across the horizontal. You'll also notice that the lines in between your values are not evenly spaced. This is what we call a logarithmic increase. Each section that we're going to describe to you is an increase by a power of 10. So let me show you how to read this. We're going to start out with a velocity of 0.01 centimeters per second. We're going to increase up to 0.1 centimeters per second. So each line is going to increase like this: 0.02, 0.03, 0.04, 0.05, and so on. Next section over, 0.1 to 1 centimeter per second. Your increase is going to go like this: 0.2, 0.3, 0.4, 0.5, and so on. Next section over is going to increase from 1 to 10 centimeters per second. Your values increase like this: 2, 3, 4, 5, and so on. Next section over goes from 10 to 100 centimeters per second. Your increase goes like this: 20, 30, 40, 50, and so on. Then finally you go from 100 to 1,000 centimeters per second, and your increase goes like this: 200, 300, 400, 500 centimeters per second, and so on. That's what we consider a logarithmic increase. Well, the same can be said along the first vertical scale on the left-hand side. This is particle diameter in centimeters. So we can start with the really teeny tiny particles, 0.0001 centimeters to 0.001 centimeters. So your increase is going to go like this: 0.0002, 0.0003, 0.0004 centimeters, and so on. Next section up is going to be 0.001 to 0.01 centimeters. And your increase goes like this: 0.002, 0.003, 0.004, and so on. Next section up is 0.01 centimeters to 0.1 centimeters. Your increase goes like this: 0.02, 0.03, 0.04, and so on. Next section up is 0.1 to 1 centimeters in diameter, and your increase goes like this: 0.2, 0.3, 0.4, 0.5, and so on. 1.0 to 10.0 centimeters, and your increase goes like this: 2, 3, 4, 5, 6, 7, 8, 9, 10. And the next section up, 10 to 100 centimeters in diameter, your increase goes like this: 20, 30, 40, 50, 60, 70, 80, 90, 100. Now the right scale actually gives you the minimum and maximum diameter for each individual particle size. So basically from 0.0001 centimeters to 0.0004 centimeters, that's clay. From 0.0004 to 0.006, that's silt. 0.006 to 0.2 is sand. 0.2 to 6.4 are pebbles. 6.4 to 25.6 centimeters is cobbles. Anything above 25.6 centimeters and greater will be your boulders. So here's how you read it. Sometimes your velocity is given to you. Say, for instance, we have a velocity of 50 centimeters per second. What is the maximum size particle that can be moved by water that's traveling 50 centimeters per second? Where you bring 50 centimeters per second straight up, see where it hits your reference line, and you follow it across. And it looks like 50 centimeters per second will be able to move clay, silt, sand, and pebbles with a maximum diameter of about 0.9 centimeters in diameter. You can also be given the diameter. Say, for instance, you have a diameter of 0.01 centimeters. You want to figure out what is the velocity of water needed to move that fragment. Well, you bring it across, hit your reference line, you bring it straight down, about 0.5 centimeters per second. So you can use this in a couple different ways. Make sure you understand the scales. That's going to be the most important on this chart. And we'll talk to you soon.